So in this part, I'm going to spend a little bit of time on walking you through this list of applications of MST. This list is from Wikipedia. It's a very interesting list. I want to just go through it with you. And I encourage you to explore these applications in further detail. Just click on these links and read more about these applications if you're interested. So on the top of the list, they've given taxonomy. Well, one very practical and present day application of taxonomy is in, for example, bioinformatics. वहाँ पर ये होता है कि हमारे पास अब पूरे पूरे जीनोम्स जो हैं स्पीशीज के वो सीक्वेंस हुए हुए डेटाबेसेस में पड़े हैं and you can do a lot of genetic analysis. In fact, you can find similarities between species based on their genetic makeup. So in that case, what happens is sometimes we have, so think of all these points as actually large samples of genetic data. And what we do is we have some kind of a distance metric, which can find or give us a numeric value for distance between any two genetic samples. And so we can, based on that distance, we get a cost. और so इस तरह से ये जो चीजें हैं ये फिर आपस में एक ग्राफ बना देती है. Okay, and it's always then desirable to find the sets of linkages which are most likely given, which will tell us that which species and subspecies are closely related. So what you want out of this kind of a graph is an MST. Okay. And in particular, in this case, you get, as I said, this MST really is an unrooted tree. So this is what you get, and this is an unrooted tree of species that are, represented by their most likely relationships, linkages. Okay, that these two are perhaps together, evolved together, and then these are closer together in terms of evolution and so on. So evolutionary biology में यहाँ पर taxonomy जब करते हैं यानी कि you divide species into classes, subclasses. So MST is applied there. Just one application. The next application that you see here is this cluster analysis. Okay, cluster analysis is a general way of well, first of all, clustering is basically used in unsupervised machine learning. You have a lot of data points. These data points could be anything. They could be documents in case of NLP. They could be, some other kind of scientific data. And what you want to do is you want to lump them together into clusters. Okay, so you can do that using various clustering algorithms, for instance, k-means and etc. So you have these clusters of things. Okay, but there are different clusterings possible. हो सकता है कि आप अगर मुख्तलिफ तरह से clustering करें तो जो आपके clusters हैं, अगर distance metrics आप जरा बदल लें तो आपके clusters कुछ और बन जाए. और किसी भी clustering की अगर आपने analysis करनी हो कि what is the quality of that clustering, so one way you can do that is that if you define all these pairwise distances between clusters, where this is another distance metric, then you can find its MST. And MST is reflective of the quality of clustering. Okay, just one kind of analysis that you can do on clustering using MST. I'm talking about that. So if you change the clustering, then compute the MST, then maybe you have an MST with less cost, and that's a better clustering, for instance. So it could become, MST could become a heuristic to guide you regarding which clustering is better. Okay, and you can perform other kinds of clustering analysis. Say you have a bunch of documents, अगर आप NLP कर रहे हैं, and you want to find out which of these documents are more kind of closely linked according to some metric. MST is one way to go about studying that kind of relationship. So another very interesting example and very straightforward one, and actually in use, is broadcasting. So जब मैं आपको शॉर्टेस्ट पाथ्स बता रहा था, तो आई टोल्ड यू कि जो राउटिंग प्रोटोकॉल्स हैं उनमें शॉर्टेस्ट पाथ एल्गोरिदम्स, सिंगल सोर्स शॉर्टेस्ट पाथ एल्गोस यूज होते हैं लाइक एक्स्ट्रा। लेकिन एक ब्रॉडकास्टिंग की जो प्रॉब्लम है, ब्रॉडकास्टिंग इज दैट आई एम श्योर ऑल ऑफ यू नो दिस, दैट इफ यू आर एट वन नोड, that node wants to send information to every other node in some subnetwork. Okay, so it wants to send it everywhere like this. It's not a directed graph. I just these are bidirectional links. Okay. So in this case, what do you want to do? If अगर आपने यहाँ से broadcast करना है, actually आपने तमाम edges के ऊपर एक एक दफा traverse करना है, right? So you want to send it here and then यहाँ से information इधर जाएगी, फिर यहाँ पे भी जाएगी, यहाँ पे भी जाएगी. इस case में it's easy to see what you need is an MST. Okay, this is for broadcasting. So what you need is, let me also write these names, cluster analysis. So what you need in this case that I'm discussing now is an MST. अगर आप अपना सिंगल सोर्स शॉर्टेस्ट पाथ ट्री लेकर ब्रॉडकास्टिंग करेंगे तो आपको ज्यादा कॉस्ट पड़ेगी, क्योंकि आप हर पेयर के लिए इंडिविजुअल अगर चेंज भी कर लें तो आपने ओवरऑल कॉस्ट आप ज्यादा दे देंगे। लेकिन अगर आपने ग्लोबल कॉस्ट मिनिमाइज करनी है तो आपको ये MST चाहिए। सो ये अगेन इस चीज़ को हाईलाइट कर रहा है कि ये सिंगल सोर्स शॉर्टेस्ट पाथ्स और MSTs बिल्कुल मुख्तलिफ प्रॉब्लम्स। इसी का एक टॉय एग्जांपल ये होता है जो आमतौर पर दिया जाता है कि अगर आपने एक गैस पाइपलाइनिंग करनी है किसी एरिया में, तो आपको टोटल पाइपलाइंस कितनी चाहिए, पाइपलाइन की लेंथ कितनी चाहिए। तो व्हाट यू नीड टू फाइंड आउट इज द MST बिटवीन द वेरियस पॉइंट्स जहाँ पे आपने वो गैस पाइपलाइनिंग करनी है। दैट विल मिनिमाइज द टोटल अमाउंट ऑफ पाइपिंग दैट यू नीड। So this is a more real world example where you are actually in broadcasting, you need the MST. Okay? So you can go on through this. I can talk a little bit more about, so for instance, this handwriting recognition. I have just looked it up and there is this paper that came out in 2016 that's really doing something that's usually done, often done in image analysis, कि आप एक इमेज को लेके तो उसको ग्राफ की फॉर्म में रिप्रेजेंट करते हैं और फिर ये उस ग्राफ में MST फाइंड कर रहा है और ये MST बेस्ड पार्सिंग कर रहा है। इट्स अ फेयरली कॉम्प्लिकेटेड method. I've not read it. If you're interested, you should go through it. But again, this paper is like out in 2016, so just 5 years old. So actually, the reason of doing this video is to show you कि जो algorithms हम यहाँ कर रहे हैं वो algorithms एक्चुअली ऐसा नहीं है कि अगर कोई एल्गोरिथम 1980 में है आया है तो वो अब यूज नहीं होता। जितना कटिंग एज स्टफ है, नया स्टफ है, वो बेस करता है फंडामेंटल स्टफ के ऊपर जो हमने इस कोर्स में पढ़ा है और पढ़ रहे हैं। विदाउट नोइंग दीज थिंग्स यू कांट डू इवन कटिंग एज स्टफ, राइट? सो या, वन लास्ट थिंग, इमेज सेगमेंटेशन। इमेजेस, बड़े इमेजेस को छोटे सेगमेंट्स में काटना जो है ये काफी डिजायरेबल होता है इन अ नंबर ऑफ एप्लीकेशंस। एंड अगेन हियर इफ यू हैव अ बिगर इमेज और उस इमेज के अंदर छोटे छोटे पीसेस हैं एंड यू वांट टू नो कि क्या ये छोटे पीस मिलकर एक बड़ा पीस, एक सिंगल बड़ा पीस तो नहीं बनाते। One way to do that is to have these little islands of pixels, and then what you do is you find their MST, and so this MST tells you that perhaps this is a bigger object, maybe made up of little eyes and nose, maybe this thing is a face, and so on, right? So yeah, so this is a very applicable and important problem. And now we will return to the algorithm that will allow us to find an MST once we have a graph. So इस तरह की applications जो मैंने आपको दिखाई, इनके अंदर image data भी हो सकता है, video data भी हो सकता है, textual data भी हो सकता है, genetic data भी हो सकता है. What you do is that there is always that phase where that kind of data is converted into a graph, and then from there on the algorithm begins. ये graph जो हमें मिल गया, एक undirected weighted graph हमें मिल गया, अब उसमें से हम MST कैसे find करें? And the first algorithm we're going to study that does that is Prim's algorithm.